Hello, sir. Welcome. Can you hear me? We have the pleasure to have you with us today. And there is one last thing before you start your talk. I would like to ask you if you wanted to have a question in the middle of your talk or you let them until the end.
Oh, sure, you can ask questions anytime.
Okay, thank you, mister. You can start now.
Thank you. Let me share my slides.
Okay.
Let's see. Where are my slides? Here they are. Okay. First, let me start with thanking all the organizers and especially Yasin who pulled me into this. I'm super happy to be here. And today I'll be speaking about modern Android development, which might make you ask a question. What is classic Android development then? So modern is a relative term, and I'm pretty sure 5 years ahead from now, we'll be speaking about very different stuff, and maybe we'll be calling what we call modern today as classic. But Android has probably a little longer than 10 years, so we had different practices, different languages, and different tools. So we'll walk over them and see how things changed and what we had, what kind of problems we had, and what kind of solutions we built to get over them. First, a little bit of history. So Android, the first SDK M3, which stands for Milestone 3, is released late 2007. At the time, it was using Java programming language. It consists of a lot of platform APIs, mostly worked on Eclipse ADT. And what it did was basically package your apps into APKs, which are simply zip files. Then, close to end of 2008, we had version 1, and with version 1, there were more platform APIs. Actually, other versions following version 1, the first few versions of Android was mostly about platform APIs and releasing new APIs in each release. Then we had, in mid-2013, we had Android Studio, which is a new IntelliJ-based tool set for building Android apps. And in 2017, at Google I/O, we announced Kotlin support, which again changed things dramatically because the language we used to build Android has changed, and it definitely provided more modern language features. Close to end of 2018, architectural components, and in 2019, app bundles are introduced. So let's rewind a bit and see those in a bit more detail. First, language. Java programming language was chosen for a specific reason. It had a very large developer base. It still has, and it's a very nice language. Most people learned it in the universities. It's a very easy to read and write language. Java, by design, also made some stuff much easier, like it didn't follow the pitfalls of multiple inheritance or other stuff. So Java was a very easy to read and learn language, and Android, it was a very good choice for Android. The tools, existing tools are all free, and Java developers were already familiar with existing tools. So again, it was a very good language with existing tool support. There were a lot of existing libraries, patterns, best practices, and basically anything you need to start with the language, you had support. And again, compared to C++, it has its own memory management thanks to the garbage collector. So it was a bit easier to learn and start developing apps instantly. If we take a look at the tools, at the time, Android started with Eclipse and a set of plugins built on top of it called ADT, Android Developer Tools. The best part of it is it's free. Eclipse is a free tool, and the additional plugins which we build on top of Eclipse are also again free. And Eclipse is widely used in Java communities. So as a developer, most likely you are already familiar with the Eclipse. And when you jump into Android, you don't need to learn a new tool. So you can make use of your existing language knowledge, existing tool knowledge, and start building apps. So it all made sense. And once again, everything was free. Another powerful thing about Eclipse was Eclipse had a large plugin ecosystem, so you instantly get integration into other tools and other plugins. You can use any source control or any other Eclipse-based plugin you are already familiar. And once again, everything is free, which is the best part. So you could just download the tools, download the SDK, and start building. Now let's take a look at the APIs. So as I mentioned, the first few platform releases were mostly about APIs. Android is released with a set of APIs, and with every release, we released new APIs. That was one of the reasons first Android releases were so frequent, 2 times a year. Then with every new release, we introduced new functionality, and we also did a lot of bugs and fixed a lot of them. So bug fixes was also a big part of every platform release. If we take a look at the history of the SDK platform releases, the first 1.0 came close to 2009, late 2008. 1.1 was early 2009. 1.5 was, again, I think it was close to mid 2009. 1.6 was released before 2010. So just in 2009, we see from 1.1 to 2. In 2010, we had 2.2 release. And with that, we'll see again the release cadence go with a similar frequency. We did a lot of releases to release a lot of functionality. And you may remember some of those releases are really to support to release new functionality to support devices. For example, 3.0 was specifically released to support tablets. And if I don't remember wrong, fragments were first introduced with 3.0 release. After 4.0, the release cadence has become more stable, and things started going out slower, but in a more expected timeline. So as you can see, starting from 4.1 or 4.4, it's a platform release every year, and it's continuing like that since then. Let's take a look at distribution. So since from the beginning, we used APKs to distribute our apps. And APKs actually are not much different than zip files. If you basically zip your binary code and name it as APK, you will end up something very similar. So the build tools basically zip all your build files into a large file which can be distributed. APKs, but with more devices, we had more configurations and different setups. And with single APK approach, you may need to include all the configurations in one single APK. Or alternatively, you can create different APKs to target different devices and upload them individually to Play Store. So let's take a look at some classic problems from the classic solutions we provided in the beginning. Let's start with language. If you're a Java developer, you probably come across those. Java is a great language, and it's easy to learn. It's easy to debug, work on. But as things progress, Java didn't include some new modern programming language features, and kind of fall behind. Still good. It's still good language. On the tool side, we had Eclipse, but we had difficulty to customize Eclipse to Android needs. We didn't have consistent UIs between different tools in Eclipse and the Android tools part. Also, the core IDE, we were not involved in the development of the core IDE, so we didn't have control, and we couldn't get everything we needed from the core IDE to support what we want to do. Now let's take a look at the APIs part, which is probably the most, okay, the previous ones were also important, but still a very important thing for developers. With every platform release, we release new APIs, as I mentioned, and developers are limited by users getting those releases. So if a user didn't get a new platform on their phone, the developers cannot use the APIs. The app-compat libraries did kind of a solution for this, but it was still hard, and there was still a lot of old devices with not really updated operating system, which made it really difficult to adopt new technologies and fixes because there were still users relying on old releases on their older devices, or not lower-end devices, let's say. And also, it was kind of complicated. The platform initially introduced some new new concepts like life cycles and storage, and it was also hard to create a navigation system in your app. And although some of these we planned and provided a solution in the beginning, such as the activity or fragment life cycles, while we progress, we realize it's not super easy to understand by developers, and people had difficulties with them. If you take a look at the distribution, once again, zipping everything into a huge monolithic APK didn't really help because adding everything to a large APK basically made it really hard for users to download, or also it was hard for you to upload when you need a new release. Building more than one APK kind of solved this issue, but complicated the process of making releases. So to answer all those questions, we've been working on for years, and I'll be talking about new modern features we have been releasing for the last few releases. This is probably my only speaker slide, so speaker note, so I'll go ahead and read this. Development tools, modern Android development is development tools, APIs, language, and distribution technologies recommended by the Android team to help you, the developers, to be productive and create better apps that run across billions of devices. And this foundation is built on 4 different pillars: language, tools, APIs, and the distribution. So let's start with the language. For the language, we have Kotlin. And if you take a look at Kotlin's timeline, the 1.0 release was in 2016. In 2017 Google I/O, we announced we officially support Kotlin as a language for Android. And surprisingly, maybe not so surprisingly, people were using Kotlin before. And this release was, this announcement was basically telling you, okay, things will work and you won't have issues when we release a new platform or a new Android Studio release. In 2009, we announced going Kotlin first, which means every new API and tool will be released with Kotlin first in mind. And in 2020, coroutines has become the preferred way of doing asynchronous tasks. And you're here, so everything before this blue dot is basically still counts for you. Why we choose Kotlin? So if you look at Kotlin first, the first thing you will notice is probably it has way less boilerplate code. You don't need to write getters, setters, or anonymous inner classes, or other boilerplate code. Actually, there's a great series of articles and videos called Kotlin Vocabulary series, and each post focuses on one keyword and shows how it can help to write less boilerplate code. Next, Kotlin also offered safety. In Java, every variable can be null or not, and so each method you most likely start with checking if the parameters you received are null or not. But with Kotlin, you can declare if the property can be null or not. And by default, every property is expected to be not null. So this really helped. I mean, think about it. Probably most of the exceptions or errors you have received is about being an object null, which you were not expecting. Another interesting feature Kotlin had was interoperability. So Kotlin produces the same compatible Java bytecode with Java, which makes it super compatible with Java, which means you can start with a project with Java and you can try Kotlin in 1 or 2 classes. And if you feel comfortable, you can later convert or still keep Java part and continue the newer features with Kotlin, which really helped the migration because we can't just delete all the code we have or try to convert it to a new language. So this interoperability was something crucial, and that's something Kotlin provided. And finally, structured concurrency is really strong in Kotlin. There's elegant asynchronous programming features which avoids callbacks, spaghetti code. So let's see these features in looking at code. First, as I mentioned, every variable is expected to be not null. If you're expecting a null value, you can add the question mark and tell the callers or the user of the method, this variable can be null. So you can then do your controls or not. Kotlin makes use of lambdas, which makes writing callbacks in a very nicer, easier way. Another interesting feature is extension functions. If you release an API, it's really hard to change things. With extension functions, without breaking the already released and sealed API, we can add new functions to existing classes, which is a very, very strong mechanism. And if you take a look at how Kotlin does it, it's a very simple process. So you are not adding overhead or doing something really magical, but basically Kotlin compiler handles and makes the function works as if it's attached to that object. Next, we have template expressions. Again, this was something we have been missing in Java, and it's pretty strong. Another interesting feature is property access syntax for getters and setters. Again, getters and setters, even getters and setters are really a lot of boilerplate code. It's not only when you're writing the getters and setters, but it's also when you're calling the getter and setter, because you basically know if you want to get and set the property. And actually, the caller also can easily understand if you're trying to get or set, because if you want to set a value, you need to pass a value. And if you're not passing a value, you're basically trying to get the value. And with the property access syntax, basically you can access the property as if it's a public variable. But at the end, Kotlin compiler basically makes all the code to call the getters and setters, which are automatically generated, which gives you the opportunity to still write your own getters and setters if you need to. And the caller can still call the property over the property syntax without dealing with getters and setters. So why Kotlin? Speed, but not as runtime speed. It's about how fast you can develop code by writing less code, and also speed of the evolution of the language. Kotlin is releasing new features every year, and it's bringing us new tools to work with. For example, coroutines was experimental last year. Now it's fully supported and preferred way to do async development. Flow is supporting streaming values back from coroutines. Extension functions, again, is a great feature which evolves your libraries and APIs to add new features and provide new capabilities to your users. And if you take a look at some numbers, actually developers seems really like it. 60% of professional Android developers use Kotlin, and 70% of top 1,000 apps contain Kotlin code. So we, as Google, we are also doing a lot of stuff and helping improving the Kotlin support. On tooling side, we have lint checks, a dedicated compiler team which works on R8 optimizations, and also annotation processing speed. Besides those, there are annotations which help you to work with. So the Java language, the Android APIs are still written with Java language Java language, which consists null, which means if you're calling a API from the system, from the platform, you may receive null. And with these annotations, basically, you can annotate methods to tell if they can be null or not. So you can even make calling Java as seamless and as easy, as safe as calling Kotlin. In this case, nullable and non-null breaks the app, and recently null and recently non-null gives you warnings that these variables or parameters can be null or not. Besides that, we also released a lot of extension libraries, extension functions in Kotlin extension libraries. These improve the platform APIs. And to give an example, this is a code piece I really like. If you want to create a bitmap, you call this function. Then, for the drawable API, we have the draw function. But if you basically want to create a drawable from a bitmap, what you need to do is you first need to create the bounds, then create the bitmap, then paint the bitmap, draw the bitmap on canvas, and call draw method on the drawable, and finally set the bounds. But with the extension functions, which I talked in the last slide, we released a new drawable extension function to bitmap. And to do the same thing, all you need to do is basically call the toBitmap function on drawable, and you get what you need. Basically, we are doing all the work, and this extension function has all the code which previously you had to write. Besides those, all the new APIs, we're using Kotlin-specific features and other stuff like coroutines and flow. Room and WorkManager are making use of Kotlin. Paging is rewritten with Kotlin and coroutines. Jetpack Compose is again based on Kotlin. And we have released docs, trainings, samples. Actually, there's a new training for Kotlin, which has been released last week or last month or something like that. It's if I don't remember wrong, the training should be called Basic Android Development with Kotlin. We also have Code Labs. I really like the Code Labs, and I strongly recommend take a look at them because with the Code Lab you can basically keep your own. You can take a look at the text or the code, and you can keep your own pace to decide how fast you want to go. And also we release articles and videos to show different keywords and Kotlin features. Kotlin vocabulary, as I mentioned before, is one of them, and I strongly suggest taking a look at them. Next, let's take a look at tools. Well, when we say tools, it's mostly Android Studio. So if we take a look at Android Studio's history, in 2013, the first version Android Studio is announced at Google I/O. In late 2016, Constraint Layout Editor is released. Also, the Eclipse Android Developer Tools support is deprecated. In 2017, Kotlin support is announced with a bunch of profilers. We released CPU, memory, and network profilers, and we still continue working and enhancing them. 3.1 D8 is released, 3.2 more profilers. 3.3 navigation editor is released for designing your own navigation. I'll go into this, but basically navigation has been a pain point, and with the new navigation system you can do things much easier in a much safer way. And with 3.6, which is released in 2020, Android Studio support view binding. And also 4.0 comes with motion editor, DB inspector, layout inspector, and other tools. Meanwhile, the new Android Studio is based on IntelliJ. It has powerful code refactoring, extensible UI for the future tools we are planning. We are more involved as Google. We are more involved in the core IDE and the plugins which are developed by JetBrains. Also, there's a tighter integration with Kotlin and Gradle. Again, we're working on link checks and quicker fixes for issues. And most importantly, it has better support for integration with existing and the new APIs, such as navigation, layout, data binding, room, and so on. With this, let's take a look at the modern APIs, or let's say a part of it. So again, if we take a look at the history, in early 2017, Constraint Layout 1.0 is released. Later in 2017, architectural components, lifecycles, view model, and room, which is a big part of architectural components, are released. In Google I/O 2018, we announced Jetpack, also paging, navigation, and WorkManager as part of Jetpack. Later in 2018, material design components are released, which helps you build more beautiful apps easier. In 2019, we announced Jetpack Compose, and we're still working on making Compose stable and give you a new toolkit to build apps. Another release in 2019 is CameraX, which helps you, which I'll talk about it later, but which helps you work with different cameras on different devices easier. And 2020, we have Motion Layout and Motion Editor, which makes building animations a very easy job. Let's start with Constraint Layout. So Constraint Layout is a super powerful layout. It kind of looks like relative layout, but in a very nicer and powerful way. You can easily create constraints to your different views or the parent view and build your UIs with those constraints. Motion Layout and Motion Editor is another very interesting feature. If you have done such animations you see in the animation on the screen, it wasn't really that easy. And although Motion Layout gives you a very easy mechanism to do this, the Motion Editor is the real gem here. The Motion Editor really helps you to build this keyframes and tweak the animation and basically build a very complicated animation very easily. If you're more interested in this, I strongly suggest you to check out the Motion Layout Code Lab. It's a really interesting code lab, and you can see the motion layout in action, which is amazing. As I mentioned in the beginning of the talk, the life cycles were not very easy. This is the activity life cycle, actually a simplified version of it. And here you also actually include the fragment life cycle, which makes things really more complicated. So previously, if you needed to do something in your activity or fragment, you need to find the right life cycles and do the registration, unregistration, or other stuff, which makes you, even using a third-party API, even starting and stopping a third-party API, very, very hard. And this was just the easy part. Doing other stuff was also very complicated. With the new approach, now the activities and life cycles are the activities and fragments are the lifecycle owners. So you can add your observers, and the observer can let you know when the life cycle is happening, and you can take the action, which makes things very easier. For example, in this code, my observer listens the on start and does something on start. With this, third-party APIs or libraries can build their own observers, so you don't need to worry about how to start or stop them in the correct way. This really helped a lot for developers and also again libraries which needs to integrate. View model, live data and view model helps you handle again. First, it helps you take the code out of fragments and activities and keep them in the view model. They're also lifecycle aware, which means if your app, if the user turns the device, you don't need to try to reload everything when your activity is created again. So view model and live data helps you separate the data from the UI, as well as handling the life cycles easier. Basically, you observe the data, and when something has changed, you get notified. And with that, you can use Room, which would be a very easy way to integrate the database into your app. If we take a look at some Room code, I know probably all of you write SQLs and database-related code in the past. If you're using Room, you basically mostly use the annotations and maybe mimic and add some custom stuff to your queries. But other than that, you add your annotations, and Room can also verify if your queries are correct. For example, here, if I type something different than Donut, Room will give a warning error and will not compile the code. So with that, again, we generate all the code necessary to connect and do these queries, and you can integrate Room with live data and use it in your view model. So all those components are built to work together, and they can make your app more robust and easy to build. As I mentioned, view model and live data are lifecycle aware, so they avoid leaks and also can recover from configuration changes easily. You can use observers to update data for inactive UI elements. Room can easily gather data from the database and make those data available via live data in your view models, which helps you separate the data from the UI. And finally, Room uses coroutines and flow, which will help you keep the database access from the UI thread and make things right. Also, if you're still looking for ways to use RxJava, which is a great library, all the architectural components are RxJava friendly, so you can go ahead and still continue RxJava. Next, navigation component. Again, I mentioned a bit about this. Navigation was super hard to build because every app has a different navigation scheme, and in every app you use different building blocks, such as different number of activities or fragments. With the new Studio, we also released templates for navigation. So basically, with the navigation component, you can create one activity which will control the navigation, and you can basically use a navigation graph to control the navigation between fragments. There is a visual navigation editor in Android Studio, which actually produces XML code, something like this. So if you want to go ahead and add a new fragment or change something without using the UI tool, you can easily do that. It's a very readable, easy to understand syntax. But still, the UI tools really help to add a new fragment and create the navigation paths to it. And from the code, if you want to navigate from one fragment to another, all you need to do is get access to the navigation controller and then call the navigate function and choose the right parameter for the navigation. Navigation also comes with safe arcs for passing data between destination, which helps you to type safely pass arguments between fragments. And navigation is mostly designed to work with single activities because if you use more than one activity, the second activity will start its own navigation graph. So each navigation graph lives under one activity, and using a second activity means the user will leave the first navigation graph and will land on a new navigation graph, which is doable depending on the needs of your app. But it's way easier if you use a single activity and control all the navigation graph inside that activity. And you can always change and do tweaks on the back handling. So you can, it comes with consistent up versus back handling. But if you need special cases, such as don't go back to this screen because the user has signed up, you can easily do that with the navigation library. And it also supports on-demand dynamic features, which is a very nice thing. Next, WorkManager. So WorkManager is basically help you to work with deferrable work. You can decide when and how the work will start. And it's guaranteed to do work on the background. It's persistent, so if your app crashes or needs to restart, the work is not lost. To support backward compatibility, it goes back to level 4, API level 14. WorkManager does a very smart trick here. It checks the version it's running on the device and decides on what features it can use. It can use Alarm Manager or other features depending on the platform it's currently running, or job scheduler. And it supports periodic tasks, chained or sequenced or parallel tasks. And you can also define constraints on the task, such as if we take a look at an example, let's say we take a photo, we apply some filters, and later we'll want to compress and upload the image. So in this case, we want all 3 filters run in parallel. Then once they are complete, because we first want to apply the filters, then we can run compress. And when the image is compressed and small enough for upload, then we want to run the upload task. This is pretty easy to achieve with the WorkManager. We can group and chain these tasks together. We can also add constraints, such as if the phone battery is low, then we may want to not apply the filters. Or maybe the storage is not too low and we are not on roaming, we don't want to compress the image. And similarly, maybe we don't want to upload if we are in a unmetered network, in a metered network, and or maybe when we are traveling. So this is all achievable with workers. This is how we start. You create your worker, you override the do work function. Every do work function needs to return a success or failure type of result. You do your job here, and later with that work, you create your constraints, such as in this case, we add the set requires battery not low constraint. So this will only run if the battery is not low. Then we create a one-time work request, add our filter worker, set our constraint, and we can do this for other filters. Then, because we wanted all three filters run in parallel, we add those as a single list to our WorkManager, and we need to call enqueue to start things work. We also wanted to compress and upload, so we can similarly create similar constraints and works and chain them by using then function. The WorkManager also supports foreground service support. So for important work, you can start them as foreground service, but use this sparingly because the system tries to keep them alive, and this affects both the battery and the performance of the device. Next, we implement the logic and return the results. Let's take a look at another interesting feature, CameraX. So CameraX is currently works with 94% of the devices. Supports API level 21 and above. What it provides is it's way easier to use, and it also it gives you opportunity to work with different settings of different devices. It has three major use cases: preview, image analysis, and capture, which I'll show you in code. So first, to capture an image, you create an image builder, set your target resolution, and call build, which will create the configuration for image capture. One thing interesting here is this is an easy step. Yet, if you were using the standard old camera APIs and ask for a resolution which is not supported, you would get an error. In CameraX, the system acts smartly and gives you something close to that. So, for example, here, if 800 to 600 is not supported, it will create something, it will get an image which is close to this, which the camera supports. So you would not get an error. Then you create the binding. Again, it uses the lifecycle owners, and you don't need to handle those. And to take the picture, you just call the take picture function. And with this, you can get the image. I need to change something here. Okay, sorry for that. And with this, you can basically snap the picture by calling call picture. So all you need to do to capture an image is to write 3 lines of code, and it will give you the image file. As I'm wrapping the API section, I'm having some issues with the Windows here. Okay, as we are finishing up the API section, we have new releases frequently. Jetpack, if I don't remember wrong, makes releases every 2 weeks. So expect new additions, new APIs on Jetpack Compose, Hilt, Paging Tree, and others. With this, let's talk about distribution, which is Android app bundles. So distribution, the app bundles are released in mid-2018, again at Google I/O. If we take a look at the previous approach and why we need app bundles, currently the devices on the market, the user devices, 3 out of 10 phones have low on storage. Which is understandable. If you want to buy a phone, you usually go for larger screen or higher specs. But the first thing you usually cut is the storage, because you can delete some app to save some storage, but you can't just stretch your screen, which makes sense. This is something I do too, but this results in a lot of issues. First, usually, if you have an issue with storage limitation, you usually uninstall apps. And once your app is uninstalled, there's no guarantee that the user will reinstall it again. They may forget about it. Second, if the app is large, then it's less likely users want to install it. Imagine you're traveling or you're in a slow connection and you need to do some task. If you see 2 apps and one is relatively way smaller than the other, you will probably go with the smaller one. So smaller downloads and increased installations help you to go with more people and get your app on more devices. So looking at the app bundles versus legacy apps, app bundles achieve smaller installs by only downloading the configuration data needed for the device which it will run on. So you don't need to spend your bandwidth to download something which your phone doesn't support. Legacy APKs, on the other hand, download everything as a package and needs to store them even if you're not using them. This, of course, leads to large APKs and all not necessary configurations and stuff on the device. To visualize this, basically, for here, when you deliver your app, each device has the functions which the user is using and needs. So, for example, here the first device needs all 3 features, but leave out 1 feature, where the third device only uses a specific feature of the app and only downloads that part. And similarly, dynamic feature delivery helps you with that. App bundles enable dynamic feature delivery, where app modules can be delivered as needed when the device goes through the process and uses that part. This has been really receiving great response from the developers. It has been currently used over 500,000 apps in production. Also, the 50% of the top apps and games are using app bundles, which is a very huge thing. And if you look at the download size savings versus monolithic APKs, it's an average of 20%, which is, again, a very good number. You're basically shrinking your app down 20% easily. So let's take a look at what we've talked so far. We talked about 4 pillars, and for the first pillar on the language, we talked about Kotlin. Next, for the tools, we talked about Android Studio, and on the API parts, we had lots of stuff: architectural components, constraint layout, motion layout, CameraX, material design components, and so. And for the distribution, we talked about Android app bundles and how to dynamically deliver the needed parts of your app. If you're curious about more of any of these, or want to learn more on those, you can check out the link you see on the screen. And with that, I think I'll switch to questions. I wasn't able to follow the comments as I talked, but let me.
Thank you, sir, for sharing with us this information. We appreciate that for you so much. Do you like to? I read the question for you, or you read them directly from the comments?
Whichever works for you.
Okay. The first question is, do we have a ternary operator in Kotlin like Java?
The question is, do we have it in Kotlin?
A ternary operator.
But the question is, do we have it in Kotlin? Yes. We do. It's basically the same syntax, yes.
Okay. The next question is, will RX Java be deprecated by the new Coroutines Flow API?
You can definitely use coroutines and Flow instead of RX Java, but RX Java is supported, and if you want to go with that, you can use it. I'm not aware of any deprecation news or anything.
Okay. The next question, what is the best solution, Flow or live data, to use when loading data from a database using Chrome component?
Well, the best solution is basically using those. You can either use live data or Flow, depending on your case. Flow is new if you're okay with using new technology and new stuff. Sure, go ahead and I see this is the same person who asked the RX Java question. So you're probably familiar with the whole RX Java and Flow approach. So sure, you can go ahead and use Flow, and you can fall back to live data or others when you need to.
Okay. The next question is, why is Kotlin interoperable with Java?
Why is an interesting question, which I'm not sure if I can answer, as I'm not one of the person who invent Kotlin. But if Kotlin was not interoperable with Java, basically you would need a new compiler and runtime for it, which means there will be no way you can use Kotlin and Java inside the same project, which would make the migration very hard. Right now, even if you don't know anything about Kotlin and building your app with Java, if you're curious, you can create one file with Kotlin and start doing some, I don't know, utility functions in that and call them from Java. And as you get more comfortable, you can use more advanced features, and you can actually switch everything to Kotlin. But if that interoperability wasn't exist, this would never work, which meant you need to kill all your previous code and switch to a new project just because you want to start with Kotlin. So the whole interoperability is a very nice thing to have. But I can't really answer why, because again, I'm not the inventor of Kotlin.
Okay, thank you, Mr. There is another question. I have a question about Jetpack Compose. Can we expect an integration with the motion layer editor?
I don't know. I need to check this.
Okay. And the last question is, can quarantine be used with the paging library?
Yes, sure, and actually use the latest paging tree, and yes, you can use coroutines.
Okay, I have one last question. What advice can you give for a beginner in Kotlin developer, or a person who wanted to change from Java the application to Kotlin? So, what advices can you give for them?
Cool. These two are very different audiences, so let me answer them separately. If you're all new to Android and looking for a new language to learn, go ahead with Kotlin. It's a new modern language with new modern language features, so most likely it would be easier to learn for you. And once again, it supports a lot of new stuff we have been releasing, and it works with less code, less boilerplate code, and still you're interoperable with Java if you need to use Java in for a reason. If you're a Java developer and looking for ways to migrate to Kotlin, well, start slow. Of course, you can check out our trainings, code labs, and other stuff, but I really recommend create 1 or 2 files in your project with Kotlin and start using it. IntelliJ also has a tool which can convert your Java code to Kotlin. It doesn't always give you 100% usable code, but it does a very good job, and you can see what Java code translates into Kotlin. And later, if you check the trainings or code labs again, you will get a better understanding because you had some hands-on experience with Kotlin. So for me, yeah, go ahead and write code. And another tool I used a lot is when you, again, in the studio, you can select show bytecode. If you select it and see the bytecode of a Kotlin file, you can decompile it to Java, which means you're compiling Kotlin to bytecode and decompiling to Java and seeing the same Kotlin code in Java counterpart, which lets you understand how Kotlin does some stuff. Like if you do that, you will see on properties, Kotlin is actually creating the getters and setters. And seeing that suddenly makes you realize, oh, okay, this part is done this way, and Kotlin actually generates this code for me. This is how Kotlin works. So go ahead and do experiment.
Thank you so much. There is another questions that they ask it right now. The first one is, what about web developers?
I'm an Android guy, and I haven't done much real web development for a few years, so I don't know. I mean, that's probably a question you should ask the Kotlin team.
And there is another question. Nowadays, we see more JavaScript-like operators in Kotlin. Can we expect something like async away in Kotlin?
That would be a bit, I mean, That would be a very similar syntax with coroutines, but again, you need to check this with the Kotlin part. This is not very Android specific. I'm not sure about the future plans for Kotlin. I can't answer that.
Okay, I guess this is all for the questions. And thank you so much. We have the pleasure to have you with us, and we enjoy with your talk so much.
It was my pleasure. Thank you for hosting me.
Thank you. See
Hopefully
you
next time in person.
later. Thank you. So, hello again, family. I hope that you enjoy also with the talk with us, and stay tuned for more events and lives like this. See you later.